Hey everyone, welcome back to the channel. So in today's video, we're going to discuss about Redis in detail and learn all its concepts. Okay. So this will be a crash course for you to learn all the concepts in detail with examples, with coding examples you will see. And also you'll be able to learn how to use Redis in your production workload. So without further delay, let's get started. So before understanding what Redis is, just first understand what is a cache first, right? I mean, in brief, I'll just explain you what does a cache file looks like. So if you see, let's say we have a server here, okay? This is your server, and let's say we have your web or application here, right? Which sends request to the server. Ideally, in a normal scenario, how does it happen? Your server sends the request, right? I mean, sorry, this is your application or client, right? This client sends the request to the server and server sends a response in return, right? So that's how the normal client server architecture works. Now in this case, let's say the application is sending the same request to the server and the server might have to communicate with the database. Let's say we have a database here, right? And the server connects with the database. When request comes to the server connects to the database, fetches some data from the database and sends it to the front end application or client. But if you see, if the client is sending the same request to the server, and let's say the server is running the same query on the database again and again, so it unnecessarily increases the load on the server, right? On the server as well the database, right? So in order to reduce the load from the database, what we can do, we can add something called cache server, right? Let's say this is my cache. So this is where the cache servers comes into picture. So let's say this is my cache server, okay? And first what the server will do, first it will check whether data exists in the cache or not, okay? If data does not exist, then it will go and fetch from the database and the database will send a response to the server. Then the server what can do, it can then write the data to the cache also and send the response to the front end also, right? What is the benefit of this then? The next time when the user comes and sends the same request, okay, let's say get me the top 10 users of the application or get me the top 10 songs of the platform or top 10 products, let's say the request is same, then the server next time what it can do, it will then store the result. Let's say this is the result and this will then store the result on the cache server, so that next time when the request comes, the server can fetch it from the cache and send it to the front end or the client. That is the benefit of using a cache server, because cache servers are in-memory servers, right? I mean, they act as in-memory server where whoever the database stores the data in disk. Reading from RAM or in-memory reading is always faster, so this way your application's performance will be drastically improved. So that's where the cache servers comes into picture. So in today's video, we are going to discuss about one such cache server, okay? That is Redis, which helps us to build our APIs faster, you make our APIs faster and integrate a caching layer in the application. One more thing is that Redis is not only about caching, it has a lot of other use cases also, which we are going to discuss gradually in our channel. So first, now let's just see how do we get started with Redis, okay? So for that we have to first install the Redis in our system. For example, if we go to Redis products, you will see that there is a community edition for that. So if you go to community edition, you will see two different options, okay? Install Redis or Redis stack. Now, what is the difference between Redis and Redis stack? So when you install Redis, it will just install the CLI tool and a Redis server for you, okay? Using the CLI, you will be able to interact with the Redis server. So basically how the things will happen, there will be a Redis server, okay? And then you have this your terminal, right? This is your terminal. For example, this is my terminal, right? And through this terminal I can interact with this server, okay, and store the data and whatever I want to do, I can do these things using the Redis tool. However, the Redis stack, what does it do? It comes with an external tool of GUI. It gives us a graphical user interface. So this is our Redis GUI. So what you can do, let's say you are inserting some data in the cache server or the Redis server. You are inserting some, you are caching some data. So how do you visualize? The one way is to you use some of the get commands available, which we are going to see to visualize the data. But using a GUI, it makes it easier to visualize the data. Obviously, you won't need this in your production workload, but for learning purpose for today's video, we'll use this Redis GUI and actually visualize the things that are being stored on the server. So this GUI client interacts with this Redis server, and Redis server sends the response to the GUI, okay, for all the requests. So using this GUI, you can actually see the data stored in the Redis server. So this is what the Redis stack is about, okay. So we are going to install Redis stack. So if you click on here, install Redis or Redis stack, you'll see there are different options, okay. As I told, there are two options coming, install Redis and install Redis stack. As you discussed, we're going to go for Redis stack. Now if you see, there are multiple options based on your operating system. There are things available, right? Linux, Mac OS, Windows, etc. And you can install it from binaries also and from Docker also. So for today's video, I'll be installing using Docker because it will be obviously independent of the OS, and I want you to be on the same page with me on the while learning things, multiple things. Obviously there won't be much difference when you install, but on a production grade, you mostly you will be installing the Redis on a Docker container, right? Docker container, and you will be having a distributed workload of Redis server. So that's how we use in production actually. Obviously you can have a EC2 machine also, and you can install it there to act as a standalone Redis server, but most of the production workload run on Redis. So today we are going to run Redis using Docker. Feel free to install on based on your operating system. That is completely fine, not an issue with that. The commands, all the concepts that we're going to discuss, it will work there also. Just for simplicity, I'm going to install on Docker. So we'll click on this link, okay. And for that, let me just start my Docker daemon. I have already let me just type in the password. So this will start my Docker daemon, right? It will start Docker as a background process. So it started a Docker GUI also, and it runs the Docker daemon as a background process, right? So we will be using this. So if you just go to the terminal, run this command. If you look at this command, what does it do? Let me just zoom in a bit. So we are running the Redis stack image. We are pulling the latest version, and we are exposing two ports, right? So this is our host port, and this is the container port, and I'm inside the container that this image will create. Inside this, there are two ports running, and we are mapping it with your operating system port. So this is where the Redis server will be running, which we saw here, right? This runs, sorry. So this runs in 6379 port, and the GUI will run on 8001 port. Cool. And then using localhost 8001, we'll be able to see the GUI. So let me just hit this command. So because the image is not with me locally, it will first pull the image from the Docker hub. So let it run. And here we passed -d. So it will run as a daemon mode. I mean, it will run in a detached mode, sorry. It will run in the background, and then we'll be able to interact with the Redis stack. So in the meantime, it is getting installed. What we have done, we are actually running a Docker container, okay. So this is our Docker container. Cool. Let me just color it blue. So inside this, two components are running, okay. I mean, inside this Docker container, two applications are running. One is the Redis server, which runs on 6379 port, and this is my Redis GUI, or it's known as Redis Insight, right? It's nothing but a GUI which runs on 8001 port. Now this is running on your laptop, correct? Now on your operating system, so this is your operating, let's say this is my Mac OS, right? This is my Mac OS. So on my operating system, I want to map my port, right? Let's say 6379 port. I want to map this port with this okay, and similarly I want to map this port with this, so that on my macOS I can interact with this through my local port. So this is my container, in the port inside the container, and this is my port inside my operating system. So that's the job of this port mapping that we have done. So that was a brief, okay, how this Docker container works. So now the image is already there, so we can see the Docker images. Okay, here this is already installed, and if you can see, you can go to the Docker desktop also and you'll be able to see this. Okay, now what we will do, we'll just see Docker ps. You will see that it has already started one container. Okay, now if you go here, one container is already running here. Okay, and ports are mapped here. So if I go to localhost, you can go simply now go to localhost 8001, and you see that we are able to see the GUI. Okay, now as soon as we add some data, we'll be able to see here. Okay, so this is the GUI. Okay, the graphical user interface that we have. Now how do you interact with the client? I mean the Redis server. I mean, how do you interact with this Redis server? For that, what you have to do, we have to get inside this container, right? This is a container that is running. Okay, this is my container, right? So I want to get inside, I have to get into this container first, then I'll be able to interact with this Redis server directly, okay, using the Redis CLI tool. So for that, what we'll do, just take this container ID. Let me just clear this. So we'll run do docker execute in interactive mode the container ID, and I'll run bash. I mean, inside this I'll run the bash server, okay, inside this container. So I'll open a bash shell. So let's just run, and if you see, I'm inside the container now. So basically what I have done from my terminal, so this is my terminal, the black color terminal you see. So this is my terminal. Okay, so this will be a kind of, you'll be able to understand how the Docker works also. This is just a extra thing that I am explaining you. Okay, now using this exec, what I did, this is my container ID, right, which you already saw. So if you see, this is my container ID, okay, 3v7. I have now through my terminal, I have moved into this terminal, moved into this container. Okay, and now I can actually do the Redis CLI command, and you see now I am connected to my Redis server, see, which runs on the 67N port. So this is a 67N port, localhost it is running. Now if I just do something like, let's say my name is Preetham, it told, okay, I have stored that thing in the Redis cache server. Now if I just do get name, you see that it gives us the cached value. Now if you see the same thing we can explore here also. If I just refresh this, you see that a key called name has been introduced, a string, and if I click on this, I can see the value here also. Now if you see, I'll be able to edit the value here also, Nahak, and same thing if I now just do here, I'll be able to see this thing, right? So this is how the Redis server and Redis GUI work together, and you can actually interact with the Redis server through this terminal. Okay, now you understood how the things are working here, right? Now what we will do, now we are done with the installation process. Now let's start with the different type of data types that we have with Redis. We'll go here, all right? If you see, there are a lot of data types available. Data types is in the type of data that you can store inside this cache server. So as you can see, Redis is not only about the strings, right? Some key and strings. It's not only about that. You can store actually whole lot of data type. So first, let's just start with the first data type, that is strings. Now if we go here, so Redis strings stored sequence of bytes including text and serialized objects and binary arrays. So this is quite simple. I mean, as we saw here, if you go, using the set command, you can actually set a value against a given key. Okay, just like we did here, set name Preetham, it was able to set the name for us. And using the get command, you can actually get the value of that particular key. Also, obviously, you can visualize this here also. Okay, so as you refresh here, you'll be able to visualize the things like what data has been stored in the cache. If you see, they're often used for caching, but they support additional functionality that lets you implement counters and perform BTH operation too. Values can be strings and a value cannot be bigger than 512 MB. Okay, that means it's a whole lot of data for us, right? I mean 512 MB is enough to store the data, okay, to string data, cache the data. If you see, there are some options available with the set command. So set nx, there is another command called set nx. It stores a string value only if the key does not already exist. Okay, that means if the key is already present, it won't set the value. So this helps for locking, because let's say I'll do set nx, okay, name is equal to, let's say I want to change to, let's say, Ramesh, right? If you send me one output of 0, right? So if I refresh this, you see that the value has not changed because the key is already used. So someone has put a lock like this, right? So this is actually useful when you want to implement locking on distributed locks. You want to, this is one way to implement the locks on it. Okay, that means if someone has already taken that key, you cannot acquire that key or change the value to it. Okay, so it's kind of locking. It's used for locking. And get, as we saw already, it is used to get the value. And mget retrieves multiple string values in a single operation. If we see here, like this, with m for multiple, with mset you can actually set multiple things. Okay, for if you see Python, it will be more clearer to you. You can actually pass object like this, key and value, key and value. At a single time you can set the values for multiple keys. Okay, and then you can pass an array of keys to get the value of all the keys that have been cached in the server. Now if you see, the key format that I've used is quite different, right? It's not like set name Pritham. They've used something like a colon, okay, with the colon symbol. Now this is a very good practice to cache keys. I mean, introduce keys in your cache server. So with a column, and how does it work is basically, if I tell you, let's say the left hand side belongs to an entity or a schema, and right hand side belongs to some ID. Okay, let's say you have 5 books here, right? 5 books in the database. So this is book. So your entity is here book, right? Let's say the book ID 1 has name something like, let's say, FOMO. 2 is, let's say, 2 steps. Like this, you have, let's say, multiple book. Let's say this is book 3, like this. Okay, now when you cache this using this format, book underscore 1 is equal to, let's say, FOMO book colon 2 is, let's say, 2 states, right? If you cache like this, for example, you will do that book underscore 1 is equal to FOMO. Now if you go to the Redis UI and refresh it, you will be able to see that there are 3 books available, okay, with all the name. And the cool part is, when you select strings in the tree view, you can actually change it, and you will be able to see in a folder manner. I mean, inside book you have 1, 2, 3, all right, and that's how you'll be able to create a hierarchy of your cached collections or cached values, all right. And the next thing is about the increment and decrement command. Okay, now using this incr and decr command, what we can do, you can actually increment the value of, if the value stored is convertible to a number value, it will increment the value. So basically, let's say you have users as 10, number of current users in your application. Then what you can do, incr users. Okay, so it will increment the count to 11. So if you want to increment by some other value, let's say users by 10, I think incr by, you see it added 10 to the previous count and it gave you 11. So you can actually use negative value to decrement the value. So that's how you can, if the value is the value stored is of number type, you can actually use the increment and decrement command, increment by command, or decrement by command to update the counters. Okay, so that was about our fast data type strings, which is quite simple, right? कुछ ज़्यादा complications नहीं है इसमें. Now let's move on to the next data type, that is JSON. JSON helps you to store data in a key value manner. So using Redis, you can actually store JSON data also, right? Now let's say if you do, I'm just showing you one Python example. If you do r.json, you have to mention like this, okay? Then you will be able to set the JSON value for this, right? So this dollar is nothing but it says the root of the document. Okay, I'll explain you in a while how does it work. So if I just do json.set, then bike is my key name and it's stringified format we are storing. Okay, and if you just do json.get bike, you will be able to get the list here. Okay, now let's just try this. json.set, let's say my data. Okay, name is equal to, let's say, Preetham, age is equal to, let's say, 27. If I do this, it gave invalid arguments. I think I have to pass a stringified version of this. Yes. Okay, I missed dollar also. It represents that this is my root command. And yeah, now if I just go here and refresh it, you'll be able to see that. Let's filter it to all key types and you'll be able to see that a JSON key has been stored. Okay, its key name is my data and you can see the value have been stored here. Okay, so this is how you store the JSON value. But there are some cool things you can do with the stored JSON value. So you can store, list of objects, list, everything you can store. And using this dollar operator, you can actually, interact with your JSON object. You can directly specify what you want to access from the document or from the JSON. You can actually use that as a place operator. For example, if I want to store, right, you can use that as a reference to specify what you want to access from the database. For example, let's say this is Apple and let's say this is something like, you can, as I told, you can ball is equal to 1 and 10. This also you can store. Now if you just go and refresh this, sorry, I have overridden the value. And yeah, if you see, the first object element in the array is a string, second element is a object here, okay, and third is a integer. So this kind of mixed data also you can store. Now using the dollar operator, you can actually reference to a particular value. Now if I want to, let's say, print the value of this, okay, I mean, what is the value of the key ball in my second object in the alert, in the list. So what we can do, you can actually use the key operator, the dollar operator. If you just do get my data, it will give you this entirely. Okay, now if you just mention dollar, okay, the one, if I mention like this, you see that I am able to get the second element. Okay, because this is 0, this is 1 and this is 2. So as we saw, this is the part to the values as JSON document. It means just the root. So using this, and then we have a few more operations on JSON. We have string length, okay, which will give you the length of your string, okay, or length of your document that you have stored. Similarly, you can store numbers also along with the keys, just like we had in strings data type. And then you can use num increment by, num decrement by, and multiply by. So multiple things you can do, and you can multiply things, you can increment, you can decrement, all those things you can perform like this also. Okay, now if you just do dot ball, you see that I got 1. All right, because my my 1th object in the array, the first element in the array is an object with one key called ball, and with that way I am able to reference to that first element of my array. So because this is my root, then go to the first element, then access the ball key. So that's how you use the dollar operator, right? Dollar operator to nest to the stored JSON object and reference to any key inside it. Then you have this delete command. You can actually do json.delete to delete elements from the stored value. If I just do json.del my data root, let's say -1, that means I want to remove this element from the list. Okay, you see that this is deleted the data, and if you just go and refresh this, see that the 10 is gone now, right? 10 is not there anymore. So that's how you use the json delete command. Now if I just scroll down, let's see if I am missing anything. Obviously you have the length, right? How many keys have been stored, what is the length, you can get those information. They can get the keys also in json.object keys, so you can play around with these things and you'll be able to get the values. Similarly, you can manipulate arrays with a dedicated subset of json commands. So for arrays, Redis has some set of commands which can operate on the arrays. For example, we create a empty array like this. Okay, json.set riders $ with the empty array. Now you can use this array append, right, which will add one element to the array. It's just like adding an element to the Python or JSON in the JavaScript list using .push method. You can then do the json.get riders. You will be able to get the data, and then you can insert multiple elements using this array insert command. Okay, and it will be able to, and you will be able to insert multiple things, multiple elements in the array. Now if you see here, what they have done is they are passing the index, okay, the element inside the array in which they want to insert the element. So that's how you can play around with this JSON commands, and you can store list, JSON documents, strings, numbers, anything you want. As you saw, if you go to the path using the $command, you'll be able to access any key in a nested manner. So there are multiple options given. You can go ahead and check it out. So you can use that double dot to recursively descend through the documents, right? You can see examples here also. They have, let's say, some nested documents like this, and using the double command, you'll be able to print all the modules. So I'll suggest you to go through this path documentation. You'll be able to know how to use this $, okay, along with the other JSON path syntaxes to access your elements in the JSON schema in a efficient manner. So that was about JSON. Before moving, you can see that you can actually set multiple things at once like this. Okay, if I just run this command, and we see here, you see one bike collection has been added, and inside that it has added 3 elements for me, right, in the JSON object: model, brand, price, like this. So you can actually set multiple keys value at once like this and store the entire JSON object. All right. So that was about JSON. Now let's just move on to the next data type, that is list. Now, what is the meaning of a list? So you must have known about the list that we use in JavaScript and Python, right? We have an array, right? And the same array we can make it work as a queue also, or a stack also. In the array you can add elements towards the end. Okay, let's say we have an array like this. Okay, this is my array. Then I can actually add element in towards the end of this. Okay, or I can add element in the beginning of this. Okay, and using these two features of prepend and append, like pushing and then adding element in the beginning, so we can make this list work like both a stack and a queue. So that's the mostly used use case of Redis list. So as you can see, by definition it means that Redis list are linked list of string values. For example, if I and using the L push, it will add one element to the linked list towards the head. From left it will add the element. With R push it will add towards the end. Towards the tail it will add. If I just show you one example, we'll do L push my books. Okay, and name is, let's say, FOMO. Okay, I have to do this. I'll push. Okay, now you see that my books is a list and one element of FOMO has been added. Now if I just refresh this, See, there is a list or data type list, and the key has been created my books, and the 0th index FOMO has been added because I did the L push. Now if I do L push again to my books, let's say next element is 2 states. So it added 2 things actually, because it considered this as a different thing and this as a different thing. Now if I just refresh this, you see that states has been added and 2 has been added. Let's say if you want to add one element towards the end of the list, you can do r push my books, then node to, let's say node to self. Now if I just refresh this, we will see that node to self here, okay, in the end. So using L push and R push, we saw how to add elements towards the beginning and the end of the list. Similarly, we have command of lpop and rpop, which does nothing but removes the element. Lpop will remove the element from the head of the list, and rpop will remove the element from the end of the list. So it's like how a linked list works, right? So it's a linked list kind of thing. Okay, so actually you can create linked list around it, and you can play around with that. So now if I just run this rpop, I want to pop one element from R books. Okay, let's say you can optionally specify the count. Let's say you want to pop 2 elements, you can mention count as 2, but by default it will take 1 only. Okay, if you don't push anything. So when I do rpop, what it will do, ideally it should remove this from the right hand side of the linked list, right? If I do node to self has been removed. Now if I see, it has been removed from the list. If I do lpop my books, you see states have been removed because this is the head of the linked list. So it is removed one element from the linked list. So you can actually mention multiple things. Let's say you want to delete 2 elements from the left side. That means you have only 2 elements. It will remove all the 2. If I just do this, you see that all the elements have been removed from it. And if you refresh this, you will get nothing. The key itself will be removed from the list. So similarly, we have L length, which returns the length of the list. Okay, if you pass L length, it gives 0. Okay, because the key itself does not exist. But if I just push one element and then I apply this, you see that the length is now 1, right? Because length of my linked list is 1. Now lmove command is used to move elements from one list to another. Basically you can maintain 2 lists, and you can run this command to move one element from one linked list to another linked list. And then L range is there. Using this L range, you can pass a range, right? Start range and end range with this command. If you see this command, the key and start and stop, what it will do, it will get you the values between the specified range, that the range that you have specified, it will access the value and give you those values. Now using ltrim, you can actually trim the list. I mean, you can remove elements in multiple elements or from a given range. So if you see below, we have a trim command. When you do ltrim command, what it will do, it will only keep those values. Okay, it will limit the length of the list to only those elements whatever you passed in the range, and it will remove the other elements from the list. So that's the job of ltrim command, right? So if I just show you once, like let's say I have task to do. Okay, task 1, task 2, task 3. Okay, now if I go here and refresh, you see I have a task list. Okay, there are 3 elements. Now let's say I want to keep only 2 tasks in my bucket. Okay, or let me just add one more task to it. So this is my to-do list, let's say. So this is my to-do list. I have 4 things to do. Now let's say I have only 3 things pending or 2 things pending. The first 2 things are pending and other 2 are already done. So what I can do, I can do ltrim task 0 and 1. If I do this and refresh it, you will see that only the first 2 tasks are pending. Other things have been removed from the to-do list. So that's how you use the ltrim command to play around with the list. Alright. So as we saw, you can actually implement queues using the L push and R pop. You are pushing element from the left hand side towards the end and popping from the right hand side, right? Basically elements are entering from here and going there in a FIFO manner, fast in fast out manner. In a stack LIFO manner, you can actually push elements and pop it from that side only, right? You are pushing things, and last in first out, whatever is entered in the list in the end, you will pop it using lpop. So that's how you can implement stack using Redis list also. Okay, so we saw all the commands available with the Redis list. Okay, you can go through the documentation. Yeah, we saw you have this delete command obviously to delete the entire thing at once using this delete command, and there are Python equivalent for that also. Okay, r.delete new bikes, r.lpush. Using like this you can implement, you can add multiple elements to your bikes list. So that's how things work here. Okay, so that was about the list in Redis, and the maximum length is 2 to the power 32 minus 1, which is huge. It's a huge number of elements that you can store in a Redis list. If you talk about the performance, list operations that access the head or tail are O of 1, obviously, because you have a pointer directly, right? A head pointer and a tail pointer. Using that, you can directly access those elements. It's a linked list, right? You know about linked list, how it works. However, the commands that manipulate elements within a list are usually often because you have to traverse the entire linked list. So that's how the list works. Linked list in Redis list works. So that was about third data type. Let's now move to the next data type, sets. Now you know about set, right? How does a set work? Set is, is a collection of unique elements in it. So using Redis set, you can actually create an unordered collection of unique strings or members. So you can use Redis sets to track unique items, let's say track unique IP addresses accessing a given blog post, or represent relations, set of all users with a given role. So you can create Redis set just like our set works, traditional set. So for that we have a command called sadd, because S for set, then you can using sadd, you can create a set. Let's say my set is, let's say, IP address, or let's say names. So this is my let's say my set I'll create, and I'll pass apple, banana. So what it will do, it will add only 2 elements because apple is repeated, right? So it's so total number of unique values are only 2. Now if you go here and refresh it, you'll be able to, a set has been created with 2 unique elements in it, right? Now using the srem, you can remove specified member from the set. So what you can do, you can it will remove the element from the list. If I just refresh this, only banana is left, okay, in my set. Now there are other commands available like is member to check whether a element exists in a set or not. I'll check if apple exists, it sends no, but if I just do banana, it returns 1. That means yes, banana exists in the set. So that's how is member works. Then we have another method called sinter, which returns the set of members that 2 or more sets have in common. It's basically intersection. Let's say I have 2 sets, right? I'll create another set called fav fruits. There I will add apple, banana, orange. Okay. Now if you see, my set has 1 element apple, and fab fruits have 1 element, 3 elements basically. 3 elements, and between these 2 sets, banana is common, right? So if you do sinter, we have my set and fab fruits, it gives you banana because only 1 element is common, right? So that's how the intersection operation works. Okay. Now scat returns the cardinality, right, in the size of the list. Let's say if I do scat my set, it will return 1. If I just do fab fruits, it will return 3. Basically it counts the number of elements in the set and gives you the count of it. Okay. Now there are other operations also, like you can do sdiff also. Yeah, see, you can do S union, just like S inter, it will basically create a union B, right? Set, it will create a union of both the set. S diff basically gives you set. I mean, it's just like, how the set, normal set works. Let's say you have two sets, right? A and B. So this is your A intersection B, this portion, okay? Right? This portion is your A intersection B. A minus B is this portion only, right? Because whatever is present in A but not present in B, so this portion. B minus A is this portion, right? Only this portion. And A union B is the entire portion. So that's how the set works, okay? As you know already about set, I am not going to explain in much in detail. So, but this is how you can actually mention multiple keys here, okay, using different type of set commands available. So that was about set. It is quite pretty simple. You can see it's the main job of set is to store unique values, okay, and the use cases you can find it here. Now sets are done. Let's move on to the next thing called hashes. You know how hash works, right? Hash is basically normal hash set or in a hash map. What do? You set, we store key values, right? Key values pair. So, and the goal of storing hash values is to access the value using O of one time, right? So similarly, we have hashes in Redis also. What does it do? It record types structured as a collection of field value pairs. All right. If I just show you here, this is how you can create a hash set, okay, or a set using Redis. You will give your key name. So this is a Python example I'm giving you, and then you can pass a mapping to it, okay, like what is the model, what is the brand, what is the type, price and all. Then what you can do, you can use the hget command to get the value of particular key, particular hash key of that cache key, right? If you use the r.hget, bike1 का model क्या है ना, यहाँ पे bike1 model is demos, so it will give you demos. Run this get all command to get all the keys, so it will give you the entire mapping, okay? Or you can access, let's say you want to access the price, you can mention the key value, you can mention the key here and key inside the mapping to get the value 4972. So that's how this hashes works actually. Now if I just clear one hash for you, as set, let's say player name is, let's say player, okay, this is my player name. So what I'll do, I'll create name as Virat, jersey num as 18, okay, centuries as, let's say 82 or 83, okay. Now if I just go here, if I just refresh this, you can see I'll just a hash set has been created with this player key, and there are three things here, right? Name, jets number and centuries. If you see, there are a TTL thing also. Basically you can you can mention expiry time for this key. You can mention how many seconds or milliseconds the key should exist in the cache. After that it will expire automatically. I'll come to TTL soon, don't worry. Now once we have set this, right, then what you can do hget command. प्लेयर का मुझे चाहिए लेट्स से जर्सी नंबर, राइट? तो मैं क्या करूँगा, जर्सी नंबर आई जस्ट मेंशन, इट विल गिव मी द, did I, yeah, sorry, the key itself is wrong here, okay, it's a jersey number by my mistake. So yeah, you can see that you are able to get the value. That's how the Redis hashes work. All right, we have hget, hset value, which is so, and you can actually use this get, which is nothing but hash set multiple get. You can specify multiple keys and it will give you the values, okay. You can just do hget player name, centuries, abcd. If you, sorry, you have to use the get, my bad. You see the name is Virat, number of centuries 82, and the third value is abcd, because the third value is nil because we do not have any key called abcd in the hash map, right? That's how the things are. So you have similarly we have this increment by command, okay. If you have numerical field, numerical values, let's say I want to increase, let's say today h increment by, right? Centuries. Let's say today Virat Kohli hits 2 centuries, so we can increase the number of centuries by 2 and the number of value increased from 82 to 84 here. Okay, that's how the increment by things work. So these are the 4 basic commands that we have with hash sets. So as you're discussing about TTL, so you can actually mention expiry time using your hash set. Let's say in multiple cases you would want the cache to expire after a certain amount of time, right? So for that you can use this hash expire or hash expire at. So here you can actually mention the particular timestamp or the specific time. At let's say 12 p.m. I want to expire this key, or at after 30 seconds I want to expire this key. Then you can use the hash expire. You can, if you want to expire the key at a particular time, particular clock time, you can mention that using hash expire at, right? Now these are some of the use cases that we already saw. For example, active sessions, right? Let's say you want to store all active sessions in a hash key. Then you can set each session's TTL to expire automatically after inactivity. Basically what you can do, you can maintain a hash map, right? Like how many users are accessing your applications right now. You can have one key and number of, now for each session you can have one key, right? User 1 you have active key. For user 2 you will have active key. Now you can, for each key you can mention expiry time. Okay, that means let's say you want to expire that user from the session list as soon as it becomes inactive for let's say 30 seconds. The other way around, if you want to maintain let's say before 30 seconds expires, at 27 expires, the same user comes and access your application, then what you can do, you can actually again mention the expire time. Okay, you can add 30 seconds to that existing user's key in the hash map, and that's how you can mention active session tracking. You can do active session tracking. For example, I'll create one hash set. Okay, sessions, right? User 1 active, user 2 is active. Okay, now if I just go here and refresh, sessions users I've created. Okay, I have not specified any limit, but if I do h expire sessions, right, user 1 should expire after 30 seconds and user 1 and user 2 both should expire. I think I have to mention number of fields also. Number of field is let's say 2, and I want to expire for user 1 and user 2. Now if I just refresh this, you'll see that TTL will be set to, see, as I go on refreshing, it is coming down, right? Let's say the user 2 became active again. So what I can do, I can add 30 seconds for that field 1 user 2. I have done a typo. I think it already got deleted. Let me just set it here. If I just refresh it here, there are 14 seconds pending. Yeah, if you see that now if I just keep on refreshing, let's say user was inactive for 10 seconds, he became active again. So what you can do, you can run this command again, it will again add 30 seconds to it. Okay, so that's how you can actually maintain a list of active users. So this is active, I can do this, it will again set the expire time to 30. Okay, so that's how you can maintain a active session list, active users list like this. So you won't want to do it every time, but using this you can play around with this expiry time variable. Right, every time user comes to the application, you obviously want to set the expiry time to 30. Okay, so if you have seen the income tax website, right, when you access the income tax website, it gives you a session of 30 minutes, right? As soon as you log into the application, you get a 30-minute window, and if you are performing anything, it will ask you to refresh your session time, right? And it will ask you to renew your session time. So as soon as you click renew, it sets 30 minutes clock to your session again. So that is one use case of using sexpire, okay, to specify active sessions in your application. So that's how you can play around with the hashes. Now I'll go to the next thing called sorted set. Okay, so if I discuss about sorted sets, it's kind of, if you have read about priority queues, right? In priority queues, what we do, when you add one element to the queue, along with that you add a weight, right, or a number to it, and based on that number, it will rearrange or sort the entire queue according to the weight assigned. So using this sorted sets works like that. It's basically is used to specify leaderboards, right? Now if you see, let's say I want and using this command ZAD, you can create a sorted set. So it's basically used to create a leaderboard or ranking in your application. Let's say you want to ranks of Pritham is, let's say, 10. My bad, I think first I have to pass the value, then I have to pass the member. Okay, now if you see, if I just go here, see that a sorted set has been created with rank 10. But if I add another element, okay, Ramesh, to the element, because Ramesh 2 is 2 is rank wise it comes first, right? So it now he has moved up to the top of the leaderboard. Let's say someone comes with ranks, let's say 11. Sorry, the person name is, let's say, persona. He moves below. So that's how you can see you are maintaining a leaderboard, right? Now let's say ranks, if I do Rahul, you see Rahul is on the top of the leaderboard now, right? Member and score. That's how you give the score to each member, and that's how the sorted sets work. So based on the score field, whatever you are passing as the score, you'll be able to maintain the list. Now if you see, there are two use cases. So you can maintain the leaderboard, okay? So highest score, you can maintain an order list of members with scores assigned. It will give you a leaderboard, and then you can use it for rate limiters, right? So when you want to implement rate limiting for your application using a sliding window algorithm, you can use this sorted set to maintain how many number of requests you want to allow for a given API, and then you can maintain that list to prevent excessive API requests for you. Okay, and if two elements have same score, let's say I want to add Aman with rank 1, right? You see now lexicographically Aman comes before Rahul, right? If I just refresh this, you'll see that Aman is above Rahul because they have been ordered lexicographically because they have the same score, correct? Now you have other commands in hash set. You can add Z range, okay? You can pass the starting and ending value. -1 is used to depict the end of the value. This is used to get the start of the value, right? So it will give you all the elements, okay, of that list in the manner that they have been stored. So 0 to -1. Let's say I have mentioned the wrong thing. Yeah, if you see that Aman comes first, and Rahul, Ramesh, Pritham, and Persona. However, you can, if you want to print the list on a bottom-up manner, let's say instead of ranks, these are marks. Let's say, right? These are marks. Let's say Persona has scored 11 marks, I have scored 10 marks, Ramesh has scored 2 marks. Instead of rank, let's say these are marks. So in that way, you want to show the persons, all the person in a reverse manner, because we are storing the marks, right? But by default, it stores the hash set stores the value in a incrementing manner. So if you using reverse range, you can able to see the values in a reverse list, right? So that means the persona has highest mark, then Pritam comes second, then Ramesh, then Rahul and Aman. So that's how you can, if you see the Python implementation also, you'll be able to see the things here, right? Rev range and Z range. So these are the some of the commands that you can implement on with your sorted sets. Then we have some other operations you can perform, right? You can filter by scores. You can use the range by score. You can mention some score, right? Like I want to see the persons or elements in the hash set whose score is between 2 to 5. So it will give you all the list in order manner, whoever has the range. Then you can use the zrem command to remove element from the hash set. So you can try out the other fields that are available. They're pretty simple. It's not very difficult, right? If you go through the documentation, you'll be able to understand properly. So you have this increment by, decrement by, as we saw. If you want to, let's say, increase the score of a particular key, you can use this increment by command. Okay, so that's how these things work. ZAdd, ZRange, ZRank, RevRank. Okay. Next is about Redis Stream. So if I discuss about Redis Stream, you must have known about Kafka, right? Kafka is a high throughput, pops up message broker service. So which is used to, store frequently generated data. I mean the data which are generated at a faster rate. For example, some of the example will be event sourcing. For example, Amazon tracks which applications you are using. It tracks your mouse movement on the application, like which product you are hovering over, where you are spending most of the time, to know your interest, right? Know your topic of interest or products of interest. So those are very fast generated data. The data is generated at a faster level. Then there are sensor monitoring. Let's say we have multiple sensors running from a vehicle, from a machinery. If you want to record the value, record the readings from those devices, you need to have some sort of high throughput messaging broker or stream service, right? So Redis Streams works similar to that, just like Kafka. So this is used to store frequently generated data which are generated at a fast pace. So you can use this Redis Stream to store this data. So that's the commands are simple. You can simply do xadd command to add a new entry to a stream. Okay. So this is the record that I've inserted. Okay. Now when you add something to this, you'll get a timestamp. Okay. This is basically a timestamp. So if you do this command, if you run this command, you see that it gives you a timestamp, right? So what does it zero means? Let's say at the same amount at this particular time, at this particular millisecond, multiple streams were recorded. Let's say you can have 10 different sensors, so 10 different users accessing the Amazon application, right? At a given point of time, at a particular timestamp t, 10 users can click on the same product, let's say, right? So you want to store that. So this zero is used to uniquely identify between those values. Let's say at this point of time, the first user's click will be recorded against this, then the second user's value will be recorded against -1, okay, so on and so forth. So that's how you can use this xadd command to create a stream of values. Then once the stream is created, then you can obviously run a cron job in the background and process those values and store it in your main database. So stream will be used to handle the high throughput, high input of frequently generated data values, and then your cron job will handle in a periodic manner. They will access the data from the streams and they will move it to the main database. So that's how this Redis streams work. Then we have some range queries which can perform. For example, using this range, you can mention the ID, okay, or the timestamp. Like from this timestamp, I want to see, let's say, 2 records. Like after this timestamp, whatever records have been generated, just give me 2 records. Or read up to 100 new stream entries starting at the end of the stream with a block of 3 seconds. So blocking is used for, before giving you the value, it will wait for that amount of time and then it will give you the value. I think I just missed the blocking thing here. So there is something called block. You can mention a blocking operation on a list, okay, just like lpush or rpop. Okay, we have blocking rpop or blocking lpop, which are nothing but the blocking version of lpop and rpop. Now what do you mean by blocking version? Now as soon as we do a br pop, right, you can then mention the amount of time you want to wait. For example, if I show you here, let's say you have added some element to your linked list, okay, Redis list against this key, and you want to wait for 1 second. Okay, let's say somehow you had 10 tasks to perform in your list, so your list had 10 tasks, and your microservices are consuming tasks from it, and they've consumed all the tasks and they've performed everything, okay, and they're waiting for another task. All right, now before the microservices want to scale down or get terminate, they would want to, let's say, wait for 30 seconds. In 30 seconds they might get some task, so they will be listening to this queue or to this list. They'll listen for 30 seconds. So within that 30 seconds, if new element is pushed, right, a new element is pushed to the list, then this this br pop command will resolve for them. I mean, whenever you'll be running this command, right, if there is no element in the list, this command won't resolve until and unless there is an element for 10 seconds. If I just show you in the code, it will be better. Let's say, okay, let's say we have created a key linked list of two elements with bikes and repairs. All right, now what I'll do, if you see now, as soon as I do this, I'll immediately get the values, okay, because I am doing bike repairs pop elements from it. So what it did, from this key, it popped one element. Now if I just refresh here, if I just show you here, yeah, in bikes, you see there are only one bike is pending for repair right now. If I again do bike repairs one, it will give me this also, right? It is basically popping from the right, but it is waiting for 1 second. All right, there is no key now. Now if I just do, let's say, 10 seconds here, so it won't resolve for 10 seconds. It will wait until it will wait and just wait that it will wait for 10 seconds to check if any new element is added to the list or not, and then it will resolve after 10 seconds. You know, you see the difference, right? How this blocking pop works. If I mention, let's say, 30 seconds here, now to show you the better use case, what I'll do, I'll open another terminal. I'll just minimize this terminal. I'll do docker ps. We'll then get inside the bash shell. Then we'll run the Redis CLI. Okay. Now what I will do, I will wait for 30 seconds here. Okay. I will wait for 30 seconds here. And because the bike repairs is empty, it is not able to push, so it will wait for 30 seconds. But if you see, if I just, as soon as I push something here, right, let's say bike 3 I am pushing, you see it immediately resolved within 14 seconds. Okay, that means if you visualize this, let's say you have a queue of tasks which you want to load balance across multiple microservices. Okay, microservices are getting the data from the queue and they are processing the task and then waiting for new task. So you can using this 30 seconds, what you can do, you can specify the waiting time for your microservices because before they are scaled down or they are killed. Because if you don't have any task, there is no point running 10 instances of your application, right, or 10 replicas of your application. So you can make them wait for 30 seconds to wait for new task. Then what you can do, you can out of those 10 replica of your microservice, you can kill all 9 of them and just have one. Okay, now as the load increases, you can then spin up new things. So that's how you can load balance task among your multiple instances of your application. So that's how this blocking pop works. So that is about the blocking things, right? How the blocking things work. Blocking rpop and blocking lpop work. So similarly, we have blocking read in the extreme also. You can mention the blocking value, the block number of millisecond to wait before the query resolves when you are reading from a given hash set, or you are reading from a given stream. All right. Let's say you're waiting for new stream of sensor records to be inserted in the record, and you want to insert in the database. So that's how this blocking concept works actually. Okay. I hope you understood that. Now let's move on to the next thing called GeoSpatial. So GeoSpatial is used when you want to play around with your geographical data. Okay, let's say you are dealing with some application like a hotel search application or cab search application like Ola, Uber, right? So in that case, this GeoAdd or GeoSearch command helps you to find the nearest available cab or nearest available hotels for a given user, or the search location of based on the search location of the user. Now, how does it work? So let's say you have, this is where the user is lying. Okay, let's say this is the user. It will have its own longitude and latitude, correct? And let's say you have some hotels here. Okay, you have some hotels here like this. Okay, now let's say this is the 5 kilometer radius of this user. All right, let's say this is the user where it lies, and there are some hotels like lying around like this here and there, and this is the 5 kilometer radius for this user. So this user will have its own longitude and latitude, and the hotels have their own longitude and latitude. So what you can do, you can list these hotels in your application using their longitude and latitude like this. Using this geoadd command, you can actually add multiple bikes. Okay, let's say we have a key called bikes rentable, then we are passing the longitude and the latitude of each bike. All right, then you can add multiple bikes like this. Okay, now if I just run this command, I have added, let's say I'm creating something like Ola. Okay, so then let's say I have 10 bikes right now. All right, so 3 bikes I have which can be rented, and they are present in this latitude and longitude. So, okay, now let's say user comes with this this latitude and longitude. A user is sitting here. So if you see, this is the latitude and longitude of the user. So these are the bikes present. Okay, now what you want to do, you want to search along this, right? Geo search bikes rentable from long lat. So this is my longitude, this is my latitude. Okay, by radius 5 kilometer with distance. Want to get all the bikes, then what it will do, it will be able to see all the bikes that are present inside this location. If you have 2 bikes here, you will be able to this geo search result will give you two bikes in the output. So then you can show it to the user. Okay, so when you are playing around with geospatial data, okay, where the latitude and longitude of your bikes, then the users frequently changes. A cab won't be there in the same place always, right? They will be moving here and around, here and there. Let's say cab is here, and after 1 hour it will be present in somewhere else. So you can actually use the dynamic data of longitude and latitude to place those cabs. Okay, let's say where you have high demand area where multiple user requests are coming for cab request. So you can actually move that data, move that cabs data to a cache in geospatial data like this, to make your searches faster. Okay, using this geo search, you'll be able to fetch the bikes latitude and longitude in a faster manner. Okay, instead of fetching it from your quad tree or geo-indexing algorithms. Using this geo-indexing algorithm, you can cache those data to make your searches faster. Okay, that's the use case of it. It's not like you will be storing all the bikes longitude and latitude here, but you can cache frequently accessed data, frequently requested data in your cache server to make the searches faster. So that was about the geospatials. Then we have bitmaps. So obviously you can play around with the bits also. You can store for a given entity with a given timestamp, given key, you can set the bits like this. So you can play around with the bit field also, set bit, get bit. It's quite simple. You can just go through the documentation. There is nothing much with this in this to discuss. Okay. Then we have some probabilistic data structure. So we'll discuss about the probabilistic data structure in a different video, because each of these will require a separate video to explain in things. I already created one video on Bloom filters, how Bloom filters works when you want to search multiple, when you want to check whether a user exists among billions of users or not in a database. So Bloom filter becomes a handy tool to make that searches faster. Instead of querying your database directly, you can use this Bloom filter. So I'll be creating different use cases, videos for each of them. So we won't be discussing about this, but you see that there are probabilistic data structures which give you approximate output. The output won't be obviously 100% deterministic, but there will be approximate output. And you can check out my Bloom filter video. You'll get to know an idea about, you'll be able to get an idea about how probabilistic data structures works. Don't worry, I'll be creating individual videos for each of them. Okay. Then we have some time series. So for this you need to, I think, install a separate module called time series. Basically the goal of this is to store time series values. Okay. In a time series values can be anything. It can be, let's say, recording from your sensors, then recording from your which generates continuous amount of data, right? You can have multiple sensors, temperature sensor, speed sensor in your plant or in your vehicle. So you can use the time series to store. There are not much of an example available here. We'll maybe discuss it about in the next video. So these are some of the popularly used data types, okay, which you can store and then play around with in your application, and cache different type of data. You saw different type of use cases, right? You saw use cases of leaderboards, then streams, then geospatial data, then sets, list, queue. How do you implement queue? How do you implement logs using this? How do you implement list using blocking add and blocking pop, so that you can distribute loads across multiple servers. So these are some of the use cases which you can actually develop using Redis as a cache tool. So it's a very quite useful tool for integrating with your application to make your data access faster and make your application load faster. Okay. So I hope you understood about the data types that we discussed in today's video. So in our next video, I'll show you actually how can we optimize the API performance from seconds to milliseconds. We'll see how to integrate Redis with a Flash-based server, and we'll try to bring down the API response drastically faster, and it will improve by, let's say, 80%, 90%. We'll see in the next video. I'll suggest you to go through the documentations. And apart from this, so whatever we discussed today was only about caching. How do you cache different type of data? Apart from this, there are actually multiple type of other use cases of Redis, which are beyond the scope of this video to discuss. It will become a little bit of advanced. I'll create a separate video for that. But I'll urge you to go through the documentations, go through each of them, understand how they work, and try to integrate it with your application. You have multiple examples you can include in Java, Go, C, C#, Python, Node.js, everything. So just go ahead and learn and enjoy. Okay. So if you found this video helpful, drop a like. Let's target for 100 likes for this video, and subscribe to my channel. We are targeting for 2500 subscribers by the end of this month. So keep supporting. So if you have any questions about whatever we discussed in this video, put them in the comment section and I'll be sure to answer them. So thank you for watching this video, and I'll see you in the next one. Thank you.